And we are live. Okay. Well, hello everybody. Of course, once again, let me make sure everything is working properly. And it looks like it is, and it is. Good. Alrighty then. So we have a lot to talk about, especially with the long range pattern. There's a lot of interesting things going on. There is one prediction I know I can make that has 100% chance of happening, and that is somebody, or most people, or quite a few people, especially in social media, will be saying winter canceled, winter fail, winter's over, all this sort of stuff because it didn't snow 10 feet of snow on December 1st or 5th, or pick whatever arbitrary date that you want. And it's always interesting because it's always the same thing, right? It's always the same theme that, oh my God, the winter isn't happening because pick a reason. So tonight, I want to explain why the warm up in mid December is so important. And I'll go back and take everyone's questions. Of course, premium member questions are paramount, are answered first. And then we're going to go check out YouTube, pick out the best one out of that one, and away we go. But before we do that, I do want to let you know we have added new merchandise to the merchandise store, which you can go check out at the main website, NYNJPA Weather. There's also I believe, a 15% off sale going on Teespring starting tomorrow. So definitely, if you're interested in a new black mug, I've actually ordered the black mug and the black T-shirt already. Of course, here is the mug right here. And of course, if you're looking for a holiday gift, whether that be Hanukkah or Christmas or whatever, there's also, you could purchase a membership as well, a gift membership, which you could do right. Let's see if I go back here. And if you're looking for a gift, just go right down here, right below this part. You could check right here, perfect gift. Boom. Make sure you click this part right here, and you can send someone a 1 year's membership. So I figure I help you guys out with shopping this year, or you could do what I've been doing, which is basically staying home and shopping online. And this is a great way to do it because you can avoid the crowds and also give your special somebody or yourself a really excellent gift. So now we got that out of the way, let's take a look and see what's going on here. Well, we have a warm front that's lifting towards the region, cold front stalling out. We have some showers approaching the area. Watch out for the Poconos and Catskills for a little bit of sleet and rain mixed in. The temperatures are right around freezing in the higher elevations. I'm worried about some slick roadways, so definitely check out, just be aware of that if you're up in the Poconos and Catskills, especially for early tomorrow morning. I definitely think there's going to be some slick roadways up there. Everyone else just showers. Not a big deal. So naturally, everyone is worried about this. Mid-December, major warm-up, right? And like I said, I guarantee you there will be people running around saying winter's over, winter's bust, blah, blah, blah. Some over-the-top individuals and some people who really like warm weather will say, polar vortex locked in. Okay. Here's the thing. In order to have stratospheric warming, you have to have a source for that warming, right? Warm air just doesn't pop up out of nowhere, right? So we have this feature here. We have this warm air building. Now, I want to show you a couple of features and explain to you why. We're going to go over the mechanisms of the atmosphere and why each part is really, really important. You don't just go from fall pattern to weak polar vortex and major winter storms everywhere in one shot. You have to have a mechanism in order to have that happen. And in order to reach that mechanism, you have to go through a process. So first thing we're going to do is look at the observational guidance, and then we're going to come back to the models, because there's a reason, especially for premium members. You guys know when you read the forecast for December, I broke it down into three spots, three themes. The first theme is the early part of December, where we have a progressive pattern, polar air masses followed by rapid moderation, a very progressive pattern, lots of hints of storms, but nothing really popping up, right? So basically your November pattern going into early December. Then we have the mid-December pattern, which is mild, which is this right here. Then things get interesting for the end of December. But in order to get there, you have to go through this process. So what I want to look at are some of the observations involved here. And some of them I'm going to kind of repeat myself on, but what I've been saying for the past couple of weeks. But I want you to understand the story here, the theme, the process. As some baseball people would say, trust the process. Well, the process of this pattern evolution is driven by known physical parameters, not just the GFS of 360 plus hours decided to split the polar vortex. That means nothing to me. Okay? What means something to me is this. You see these observations here with this transport? Okay, so what this means is that if I have warm air in the mid-latitudes, and we are in the mid-latitudes, this is the mid-latitudes. So you have this warm air in the mid-latitudes. And observations and model guidance, right here, continues to show this transport from the mid-latitudes to the higher latitudes in the stratosphere. So this is why we've been seeing over the past couple of weeks, especially in November, we saw one stratospheric warming event, about moderate event, but it disrupted a polar vortex. It weakened it. Then we had a weakening of that transport. And so the stratosphere cooled down. In fact, let's see here. Yeah, here it is. Here's the process right here. Let me refresh this. There's our warming initially. Then when there's our cooling. Right? And then warming, cooling, and then here comes our warming redeveloping. Remember what I said over the past couple of weeks. Note that we continue to see this warming area here around the tropics and mid-latitudes. Well, that buildup of warm air has to be transported somewhere because the atmosphere must find a balance. And so as a result, that is how we transport and develop that balance, okay? We start to initiate this transport here, and this, notice the vectors here, the lines, okay? The longer the line, the stronger the vector. The stronger the vector, the stronger the transport. The stronger the transport, the better potential for stratospheric warming and disruption of the polar vortex. So again, we're still dealing with observations here. We're not jumping into models yet, okay? So we have that set up here. Then we have tropical forcing. Now, you might say, Stephen, what do you mean tropical forcing? Well, remember what I said about the convection. When we have an east-based La Nina, which we clearly have here, okay, you can see right here, the coldest anomalies are off towards 1+2. And we can show this, minus 1.5, Nina 3, minus 1. The further west we go, the warmer it gets. So that means your greatest suppression is towards South America, and your least suppression is towards the date line. That is why this is so important, because this convection helps to enhance that transport process. Okay? So you're having a rising motion here. Then you have signs of a weak La Nina, okay, which we could see via the SLI. Now remember, this is all coming together. Weak La Nina means that the influences of La Nina are weaker than normal, which means that your polar jet stream can amplify but can also support high latitude blocking and also support that process of disruption of the polar vortex. See, I want you guys to understand the whole four-dimensional factors here, okay? Everything involved, the tropical forcing, the transport mechanisms, everything involved here that we're looking at, that the models at times do not handle very well, especially disruption of the polar vortex. Okay? So, we have the tropical forcing, we have a better idea, and we are seeing in the forecast here, by the middle of the month, the MJO moving into phase 6 and phase 7. Now, phase 6 gives you this outcome. Mild, right? In fact, let's pull up the 300 millibar jet on the European ensemble guidance, shall we? And we'll do 12Z. And you can see during that 15-day period, this right here is textbook for an MJO in phase 6. It transports specific air into the United States, produces a generally mild pattern. You may have seen that talked about quite a bit on Twitter. That's supposed to happen. But notice that the guidance starts pushing into phase 7. It's trying to instigate that shift. And we see it through the end of the month that MJOs start to go from phase 7 towards phase 8. Now, how fast it does that is still in question. The operational guidance keeps it in phase 7 through the end of the month. Some of the ensemble guidance takes it through phase 8. Some of the outliers take it all the way into phase 1 and 2. What that generally means is that, hey, the model guidance is trying to see the convection, which we could see right here, but it's having a hard time dealing with that, with how that evolves. Why is it having a hard time dealing with that evolution? Especially the GFS. GFS is having a serious problem. And the reason why is this right here. Let me pull up current storms. Say hello to a typhoon. And this typhoon, well, it's going to be curving towards the northern Pacific over time. And it really, really has my attention. Because the potential of this typhoon, let me refresh this, is that it's going to start to interact with the polar jet stream in the Pacific. Now, it's not going to lead to a direct recurve and intensification, but it's causing some problems with convective feedback, and that's why we're having some of these problems with some of these models. So that's why you're seeing some pretty wild solutions as you get beyond day 10. So this factor is part of that tropical forcing that we're watching. To tie everything up in a bow, I take you to 10 millibars on the earth.newschool.net. That's a free website, by the way, guys. If you want to check it out, definitely do. So this is at 10 millibars. And the reason why I want to take you here as my final stop before we go to the model guidance is that way you could actually see the transport. So here we are at 10 millibars. And you can see that transport from the tropics through the mid-latitudes up to the higher latitudes in the stratosphere. We go to 70 millibars. Same evolution. And then I'm going to jump down to 500 millibars. And you see this process right here? Right around the date line, you see this transport going right into the mid-latitudes? There's your heat transport. So everything's connected. So the way I'm seeing this set up, and now we'll go to the model guidance here, and we'll pull up the warm weather, the temperature anomalies. I want you to keep an eye not just on the warmth, but watch what the cold air is starting to do over the 15-day period. So you have all your cold air built up in Alaska, and it continues to feed back on itself. You have one lobe that drops into the eastern United States, it pulls out. Then we get our warm up. Meanwhile, we get our cold air building up here in Alaska again. There's our warm air building up. That's going to eventually get transported up towards the polar vortex. Now look at what's happening with this Arctic air in Alaska and Western Canada. It is slowly sinking south. So this whole process starts to set up that interruption of the polar vortex, which we could see on the European and the GFS model. But in order to get this interruption, in order to get this warping and weakening of the polar vortex, you must build up a warm air mass in the mid-latitudes. And when you see a warm air mass building up in the eastern and central United States, the result, about 7 to about 13 days later, based on all the analysis I've looked at over the years, translates to a disruption of the polar vortex and a return to Arctic air when you have a setup like this with that transport that we've been talking about. So look at this whole process like a conveyor belt. From the mid-latitudes, it curves via centrifugal force. It curves and then swings back towards the poles. So again, the mid-latitudes, in fact, here's your warm air. Okay? Your warm air, it starts off in the troposphere at the mid-latitudes, works its way up into the stratosphere in the higher latitudes, and disrupts the polar vortex like a rocket. And so that is what we're seeing in this model guidance here. There's your transport. And you could also see it on the GFS guidance. There's your transport. So the key thing I want you to understand is that as this process develops, you're likely going to experience a lot of model solutions that are going to be all over the place. And you're going to see a long-range guidance struggle quite a bit with this whole evolution. It typically does. And you're going to have some solutions that are going to be very warm and some that are going to be advertising a major Arctic outbreak that would disappear in the next run. Don't get caught up in that. And there's also going to be plenty of phantom storms until I'd say about the 20th, okay? What I mean by phantom storms is that they show up 10 days out and then they disappear by day 7 days out. We've already seen that quite a bit. I expect to see that continuing until we get toward after December 20th. But what you want to see when you get to 10 days from now, basically Saturday the 12th, is that you want to start to see heights build up here, which is a sign that this polar vortex is about to get knocked down towards Canada. And what the goal is to have a stretched polar vortex with the polar vortex either splitting or moving towards North America. If that happens, game on. That's the concept. That's the idea. Okay, that's the forecast idea. That's why I am not concerned about the warmth that builds up in the middle of December, because it has to build up in the middle of December over the mid latitudes in order to create the pattern that we're looking for. So with that, I'm going to take your questions, and then I'll jump into YouTube as well, and we'll take some of those questions. But we're going to start with the premium ones first, and we'll start back here all the way up to 8 o'clock. And actually, okay, Matthew Myers asks, is the MJO still expected to enter phase 8 in the next few weeks? I expect it to, based on the observations that I'm seeing. Let me go here. There we go. I do expect it to. The question's not if, it's when. Okay? If I continue to see the convection building as it does, and I'm expecting the La Nina to start to weaken as we move through December, I think that's going to allow for that phase 8 evolution to take shape. I am not sure if that is happening December 20th or December 25th, 26th, somewhere around there. But I do expect it to happen. I'm just not sure on the timing yet, because I just want to see what the evolution of the convection is and the process of the MJO wave as we move through the month. Let's see. Card asks, per space weather, 4 sunspots today. Yep, I know. About 2 to 5 so far over the past week. All the sunspots have been uncomplicated, stable, magnetic field. Yeah, they've been weak. Absolutely. The solar activity from solar cycle 25 has not been impressive at all. And that's for some of you guys who are new. The reason why we're talking about the sun is that we're keeping an eye on the solar impacts on the upper stratosphere and the ionosphere, and the potential for a solar minimum to actually take shape. Usually, when you see a solar minimum take shape over the next couple of decades, each cycle becomes weaker and weaker. So we're keeping an eye on just how strong the sunspots are in solar cycle 25, which thus far have been, well, less than impressive. That leads to support for a grand solar minimum as we move through the next couple of decades. So it's kind of a science-y type of stuff, and it's kind of out there. It's like really, really long-range forecasting, but it also has an impact on what's happening now in terms of how it impacts the buildup of ozone and whatnot. So, in fact, let's see here. This one right here. I've been following along the ozone concentrations and seeing how that takes shape. When you have an active sun, even in this state, it cools the stratosphere overall, but it also supports the potential with that transport that we're talking about of creating pockets of ozone buildup, which leads to pockets of warmer air and pockets of stratospheric warming, which can destabilize a polar vortex and lead to a very volatile stratospheric environment. So there's a lot of moving parts in that evolution. So that's why we've been following that along for quite some time. Is there a coronal hole that we are supposed to get particles from on or about 12/4/2021? What expected impact should that have? Based on what I've read, not too many impacts. It looks like right now that we're going to miss the brunt of it, but I'm keeping an eye on it. With solar science, again, there is always some uncertainty in the forecast because it is still a really, really new science. But I will say, don't be surprised if you have some problems with your cell phone technology and some Wi-Fi issues because of it. Let's see here. Good evening, everyone, of course. Okay, Denny Cox asks, can you explain to us why exactly this warm-up mid-month will only be brief? As a snow lover, I get nervous. Okay, the reason why is because of what I'm expecting to happen after that warm-up. Now, here are some things that I'll be watching for. What if the stratospheric warming event fails, which can happen in a realm of possibilities. I don't think it will. And the reason why I don't think it will is because of what I'm showing with the EP flux. Okay. Those are those vector lines. If they were pointing the other direction, I would not be as confident because it's a lot harder to get that transport when those vectors are pointing down rather than up. Okay. You want the vectors pointing down when you're inducing stratospheric warming via low solar activity. So, for example, low solar activity allows for the ozone to build up. That leads to a buildup of warm air at 1 millibar down to 10 millibars. In order to get that transport and impact into the lower stratosphere and then therefore the troposphere, you need those arrows to point down. When your process is reversed, in which you're trying to transport warm air from the mid-latitudes in the troposphere, where we are, up to the stratosphere, you need those arrows pointing up. So since the arrows are all pointing up right now and have been for like mid-October, and there's no sign at all of that changing because of the QBO state being negative, that tells me that you're more likely to see the stratospheric warming events continue. If we were not in that state, then I'd be very, very concerned about the mid-December warmth because there would be nothing to change it. There would be nothing to transport that warm air towards the stratosphere, creating the processes that we're looking for. So it's all about being in the environment to support that evolution. Let's see here. This is from Card. I remember one very snowy, stormy winter where it was pretty mild and calm right up to mid-January, and then we got clobbered until late March. Yes, that's absolutely true. It could absolutely happen. See, that type of weather pattern, what causes that is you have the above normal snowfall in Siberia, which I'm sure many of you have heard about, the theory from Dr. Judah Cohen, which is a wonderful theory, and it actually works out pretty well for most of the time. There's always some wild cards to mix in there, but for the most part, it works out nicely. And so that theory is based on you get all that cold air built up in Siberia, which builds a ridge, builds up heights. Those height builds up as a result, starts to basically interrupt the circulation of the polar vortex from Scandinavia into Greenland. And as a result, you end up with a weakening polar vortex and at times either a stretching or splitting of the polar vortex. That process is still in play. That's another process of potential interruption of the polar vortex. And that usually has an impact from mid-January through early March. So that's essentially what you saw. And that is essentially what can still happen this year as well, on top of everything else that we've just talked about. Is a typhoon in the Pacific a wild card? Somewhat. Like I said, I'm not looking at it as being a strong impact, but certainly something that is creating a little bit of havoc with the convective feedback parameters, especially in the GFS and in the Canadian guidance. It's having a real issue. The new updated Canadian guidance that was just put out, I think today, actually is starting to show some improvement in handling those features. So we'll see if that gets fixed. Hey Steve, this is from Denny Cox again. What's your early thoughts on the overall pattern for January? I want to hold off on that until I start to get a better idea of what happens for the end of December. And I also want to see just how strong the ridge is that builds in Scandinavia towards the end of the month into the Arctic Circle. If I get a good handle on that, and then my theory works out with the La Nina evolution, which I think it will, then I will have a really good idea of what to expect for January. But I kind of want to get a little bit more data before speculating on that. But I will say, if I'm looking for a stormy, cold weather pattern, I would look towards early January and late January for an evolution of that process taking place. But I want to wait until I get more data to really dive into that and provide a more detailed analysis. Uh, let's see here. Cardex, because any 2 weeks or so period is representative of what the entirety of 3 months period will likely be. How do you handle that? Okay, so yeah, I mean, look, the one thing with handling the general public, which, look, I thoroughly enjoy talking about the weather to the general public and to all of you guys on YouTube, on Twitter. You try to educate and explain, okay, this is the process, this is why. This is why you would support a cold winter or a warm winter, and when things go wrong, to understand what that process is. There's some people that just, well, frankly, they just troll for whatever reason. So you just deal with it. And if any of you are young meteorologists, you're going to have to learn, especially in this day and age, of the mute button, okay, on social media. Any of you guys who are young meteorologists who are maybe in high school or college or maybe ever wanted to be, let me tell you something. You are not required to be harassed. If someone is harassing you on social because they didn't get their amount of snowfall, you have every right to mute them. Okay? Just for your own well-being. Okay? And no one has a right to bash you or give you drama. Or you can do what I do. I just give them calculus problems. I'm like, oh, okay, well, if you could solve this, then you could tell me I'm right or wrong. Okay? Because, you're trying to forecast chaos. So you try to figure it out, and sometimes it works out, and sometimes it doesn't. But the important thing is that you own it every time. Let's see, card actions. We can get another Boxer Day blizzard, and when it warms up in January for a couple of weeks, they'll say winter is over because the term January thaw means nothing to those on the internet. Some will. Some are really good, and some say, hey, look, we had our blizzard. I'm done. You never know. But you can't, you just deal with it and go on. Let's see here. Is the warm up about a week or so before the cold air pushes the basis or part of the basis for snow ice a week after thunderstorms, in that theory? There is that process. That is part of the process, depending on what region you're at. Some people take that a bit too literally, but there is a physical parameter involved in that theory. In that if you have thunderstorms, obviously you have a lot of warm air. And you're having a cold front that is transporting or driving that warm air mass out. So that warm air mass is being lifted and transported out, which may be part of that process that we're talking about. You don't need thunderstorm outbreaks to have this process take place, but it can certainly be part of that process. Absolutely. The concept and ideas here make a ton of sense. What can make this all go wrong? Excellent question. Okay. One thing that I don't think would happen, but could, is that you get an intense Kelvin wave that rapidly cools off the western part of La Nina and throws the tropical forcing out of whack. I don't see that happening, but it's certainly, let's say, a 1% chance that something like that could happen. Another thing that could happen is an unexpected mixing of the ionosphere with the stratosphere, which happened a while ago, which happened, was it 2 years ago? As far as you guys might remember, 2019, where it caused a rapid cooling of the stratosphere and basically blew up everybody's winter forecast. Everyone remembers that, and believe me, I've been keeping an eye to see if there's any inkling of that in any way, shape, or form. But that could happen, technically. That could cause a real issue. If the vectors I was showing you, if they weaken by the middle of December and we don't have as strong of a transport, which means the stratospheric warming isn't as strong, that could be a factor. That's pretty much all I got. That'd probably be the issues that could go wrong. Oh, here's a good one. You have the stratospheric warming, all that takes place, but the polar vortex splits more towards, here, let me pull it up here. Okay, so it does all that warming and stuff, but then the polar vortex decides to say, you know what, I'm going to drop towards the Pacific. That would be not good. So that would cause a massive warm up over North America and also China for that matter. And Alaska and the Aleutians would get a record breaking cold outbreak. Don't expect that to happen because of this evolution of this ridge, but that would certainly put a crimp in the forecast. Another factor is that if we have this evolution take place and that the polar vortex decides to shift towards China, but when we take a look at 50 millibars and the evolution on the GFS ensembles over the 15-day period, we're seeing more of a focus towards North America. And if you really want to take a look at the GFS, the operational GFS, okay, we'll mark that through. You can see where it's heading towards. It's splitting towards North America. So I'm not seeing any hints, even though I don't 100% trust the GFS, especially this far out. What I would look for if I using this guidance is there any hints, like where is the strongest theme or focus in the model guidance, okay? I wouldn't go out and say, post this and say, well, the pattern's definitely going to do this based on what I'm seeing on the GFS. But I would keep an eye. If I saw this bleeding in like this would tell me, okay, this should lead to the polar vortex shifting towards our neck of the woods rather than towards Asia. So those are all factors I'm going to be keeping an eye on. But that's what could mess up the pattern. If that doesn't happen, if that shifts towards China or that shifts towards the Aleutian Islands, then that would be a major problem with the winter forecast. I mean, it would just nuke it completely. Let's see here. Does the hurricane season have an influence on the winter weather pattern? A lot of people try to make that connection. There's actually been some research on that. And there is more of an impact on the Pacific tropical seasons and North American winters in terms of transport of storms in the Western Pacific towards the Aleutian Islands rather than the evolution in the Atlantic. Now, you could take some cues on what's going on in the Atlantic with the winter in this respect. If you have a strong La Nina during the summer, right, and you have an active hurricane season and you have that strong La Nina in place, then more likely you're going to end up with a warm winter. Not anything to do with the actual hurricane season, but more due to the overall tropical forcing state. So in that case, then you would end up with a warm winter. In our case, we have a weak La Nina and a hurricane season that was above normal, but it's easy to be above normal if you keep on adding subtropical storms to the number. Just saying. So there is that factor as well. You also have a positive AMO state, which is basically all that warm water that we've been talking about here. See this out here in the Atlantic? So you have all this warm water here, cooler out here with the negative AMO. But when you have all this warm water out here, it supports the evolution of a stronger thermal gradient over the eastern United States, which can lead to more cyclogenesis. If the reverse is true, if you had a lot of below normal water out here, that would lead to a weaker thermal gradient and therefore a lower potential for East Coast cyclogenesis. So again, I wouldn't call it a direct impact, but certainly a factor when you consider what caused that above normal hurricane season. Chance of a white Christmas from Paul. I still stay 10% chance. Climatologically speaking, the more you are in the interior, the better you'll have, which is obvious. It's Captain Obvious right there. In the Hudson Highlands, the Poconos, the Catskills, those areas, I really don't like to call for that for the coastal plain because you have a lot of warm water, and this year it's above normal, which alters the boundary layers, which tends to lead even with like a light snowfall, it's harder to accumulate. So I really don't like going for that forecast because it's so rare and everything really needs to pan out. So I stay at 10% until I see something that I can actually sink my teeth into and actually look on like a mile guidance. And when I say mile guidance, I mean around 120 hours, not something that's 10 days out, that comes and goes based on what we're seeing here. Let's see, cardiac accidents. With the way the last couple of years have gone, don't discount the old forecast bus becomes rise from, Shaluta, rise from the Pacific. Yeah. You definitely have to watch out for those forecast busts. No worries about that. Could this typhoon cause the same impacts like Nuri did in 2014? I don't think so. It's not the same strength. Not based on what I'm seeing right now. Rob Allen asks, I know we don't like to talk about other Mets, but a certain Penn State wrestling loving meteorologist about the similarities of 95-96 and the current pattern almost to the day. I know you believe no pattern is the same, but that is period many call the Holy Grail. Any comments? 95-96, okay, for those of you who may not be old enough to remember 95-96, I do, okay, and this is during the days when the Weather Channel was actually pretty good. It actually showed the weather. It was probably one of the most amazing periods of winter weather that I have ever experienced. I mean, every week there was like 2 snowstorms a week, and we had like I think about 12 to 14 storms, and it wasn't like like rain to snow or snow to rain. I mean, they were bona fide winter storms with snow and sleet. It was a crazy period, and it happened based on the polar jet setting up in such a way that you had perfect high latitude blocking feedback on itself with a negative annual pattern. And you had your Arctic air basically locked in around the Great Lakes, bleeding into the northern mid-Atlantic, and wave after wave of low pressure pulling moisture up from the Gulf of Mexico to support storm after storm. And they weren't strong storms. They were just storms with a lot of moisture interacting with Arctic air. Can it happen again? Sure. Is it going to happen this year? Basically, you're asking, can a historic winter happen? That's what you're asking for. You're asking for a top 3 winter snowfall for New York City and Philadelphia. That's what I call that's something. I don't feel confident in making those type of comparisons because it's such a unique setup. What happened in 95-96 was a perfect scenario. Okay, it's what you would call a thread the needle pattern. What I mean by that is that everything aligns so perfectly that it's like if you're ice skating and you get a perfect 10 and then expect every time to get that perfect 10. It's really, really hard to pull off. But are the ingredients there to cause it to happen? Yes. Yes, they are. Would I be forecasting for that? No, because that's going to lead to a lot of disappointed people if just one factor in the pattern is off by just a little bit. I mean, just a little bit. Like, for example, if the ridge over Greenland sets up more towards eastern Greenland than western Greenland, then you don't get that pattern. That little bit. That's how perfect it was. So I really don't like using those examples because, man, it is really, really hard to lock in. Not to mention the fact that we're also dealing with different parameters involved in terms of climate and whatnot compared to 95, 96. I will say something that would favor that pattern in this current environment is that with below normal sea ice, you're more likely to get that high latitude blocking and that disruption. So that could be one way to pull it off. But I wouldn't forecast for it. I sure as hell wouldn't advertise it. Okay, I'd wait until I actually have more reliable data to actually say, hey, look, the 500 millibar pattern is setting up in a very similar way, and then go from there. That's why I don't like using those comparisons. Do you think there will be many sleet and freezing rain events this winter? Absolutely. Yes, absolutely. If the negative NAO idea works out, which I think it will, then you're going to have a lot of strong high pressure systems around Maine and around the St. Lawrence River Valley. You're going to have storms that are going to try to. Miller B storms are very, very much known for a lot of snow, sleet, and freezing rain events. And I am very concerned about that potential in the Delaware River Valley, central New Jersey, especially around Monmouth County. You kind of get this bowl in the middle of Monmouth County, right around Freehold, where you get cold air locked in and you get these sleet and freezing rain events. Worried about that. In northeastern New Jersey. And then if you get a storm track heading up towards the Great Lakes, definitely for northwestern New Jersey, the Poconos, Catskills, Hudson River Valley, you name it. So short answer, yes. Very, very much concerned. Let me take a look and see what's popping on YouTube land. What are my thoughts about cats? Well, it depends. I personally like Thundercats. And what's the cats I really like, Hunt? The ones. What are the cats I really like? The ones that.
Oriental short hair.
Yeah, those things are cool. I like those. I like cats. So there you go. That is the dying question on YouTube.
Like Bellum.
Yeah, Bellum. There we go. Lots of people on Twitter say any cold now is too little too late. I gather listening to you that is not true. I don't even know what that means. Any cold now is too little too late. It's December 1st. It's the first day of meteorological winter. I don't understand. I want to be careful here. I don't understand the idea that because it's not a 1930s knockoff Christmas movie with snow everywhere by December 1st after Thanksgiving, that winter is canceled. At least for our region. By the way, a lot of those movies where they talk about winter and snow and all that stuff, that's a lot. Most of that's in New England and in the upper Midwest and the plains, northern plains, where you're climatologically more likely to have snowfall on the ground. You are not going to have a white Christmas in New York City, at least not the past 50 years, based on climatology is concerned. But there is no such idea. There is no such thing as using up cold. It's not like there's like a budget each year and that you're given a budget, and if you use up all your cold air, then you can't use anymore. There's nothing like that. It doesn't work like that. This isn't a Will Pond era New York Mets where there's a budget, unlike anymore, apparently. So you have cold air that's already building up in the Arctic. That's not disappearing. So I'm not entirely sure what that thinking is. Too little, too late. It's not like we're in February right now. We're waiting for a cold air mass in March. That'd be too little, too late because you have the cold air mass moderating. We're moving into winter, so don't really understand that. Let's see here. Rob Allen asks, bringing this up because I saw you mention on Twitter. What do you think of Dr. Ventris data showing the standard MJO wave being the 10th strongest on record? It's an interesting chart. It's an interesting MJO wave, but it's interesting in that it really hasn't had the impact on La Nina like some people thought it would. A lot of people are saying, oh, this is a spike that's going to push La Nina into a strong phase, and I really haven't seen that. See, what I try to look at when I'm looking at these mechanisms is how they have an impact on the pattern overall. I gotta be honest with you, I've not been impressed at all. But it's an interesting data point, and it's going to be interesting to see how that corresponds to the rest of winter, because there's variable factors on how that translates to the winter after that type of MJO evolution. Some have been very, very impressive winters, and some have been real duds. There's a wide range, so it may not have any direct impact at all on the pattern overall. I think that the primary factor for this upcoming winter is going to be the polar vortex. I think that's going to be the most important factor, the most important feature here. I would not be surprised by January that you're going to see a whole bunch of media stories about the polar vortex is coming, and it's going to act like Sharknado, and everyone's going to be flipping the hell out. But I think that's going to be the primary factor. If that gets disrupted, like I think it will, boy, we're going to see a flip. Let's see here. Oh, I'm awesome. Well, thank you. I try. Let's see here. Is the Arctic air mass this year bigger than usual? Well, let's see here. That is an interesting question. So let's see if I can find the answer. Let's see. Where should I? You know what? I'll use the GFS. I'll try to see if I can do Northern Hemisphere. And maybe that might not work. But I want to try and see if I can find temperature data to set up one way or the other. It's going to be hard to pull off. I really haven't seen anything that's significantly unusual about the Arctic air masses. But that reminds me of something I did want to show you guys that I forgot to show you. Okay, so I'm not really seeing anything that's saying like well above normal Arctic air mass or well below normal. It's pretty much standard of what I would expect. But one thing I want to feed back on. Remember when I said, gee, I'm more likely to see the polar vortex shift towards North America. One thing that I am watching very carefully to see in model guidance moving forward, keep an eye on this area right here and see these heights over here. Look what happens as we move forward. Notice very, very below normal heights over North America. It was more impressive in the 0Z guidance from last night. So I'm going to see if that evolution shows up. But the reason why I'm very interested in that is that when I take a look at Siberia, which is kind of the other side here, I'm seeing this weaken, and the area, actually, you know what? Hey, stupid, you probably want to actually put this on the screen. Okay, so here we go. Okay, so around Siberia, you're seeing this shift of the lowest 500 millibar heights weaken. But then over North America, you're seeing them get lower. Now, why is this very, very interesting to me? The reason why I'm very interested in that is that if we are seeing indications at 500 millibars of the strongest below normal heights over North America, that is a sign that you're more likely to see your coldest temperatures over North America rather than Asia. Why is that so important? The reason why that's so important is that it reduces the amount of transport I need to get Arctic air and polar air into the mid latitudes. I'm not taking it from Siberia, I'm taking it from Canada, which means I have less of a transport needed to get that cold air here. So the fact I'm seeing these below normal heights focusing towards North America means that you're more likely to see your Arctic and polar air masses focus towards North America and better potential of transporting them towards the mid latitudes. Also, this is a sign that you're more likely to see above normal heights start to return around Greenland. So, when we take a look at anomalies here, here we are today. Nice little sign here of above normal anomalies going from the Atlantic into Greenland, which would transport, which supports currently our Clipper pattern that we're in. Look at this evolution. Look where we're moving towards. We're moving towards gradually with heights here gradually pushing above normal. This is still a neutral to positive Arctic oscillation, but you're seeing this evolution slowly taking place. Now, when I pull up, let me go to EPS here. And we'll stay with 0Z just to keep everything even. Look what the EPS is starting to do here. It's starting to force this polar vortex down here. Again, this is towards the middle of the month, right? So here's your zonal jet taking your Pacific air. There's your polar vortex shifting at the tropospheric level towards North America, and there is your mechanism setting up. In fact, let me see if I can get a better look here of it. Aha, here we go. Perfect. This is going to be cool. Okay. So take a look at this. You see this right here? This tells me that this polar vortex must get knocked down into North America. You might see a split, but the stronger one is towards North America. Meanwhile, this split retrogrades towards Greenland, and it forces this factor here more towards the Gulf of Alaska, and this trough shifts towards central and eastern North America based off of this ridge here. This ridge here tells me teleconnects to a disruption in the polar vortex in this mile guidance. The 18Z guidance, let's see if it does any type of hint of that continuing. And yes, we do. There we go. There's your disruption. It's taking place. So, guys, what I'm saying here is that I don't care so much about the results of the model guidance 10 to 15 days out. What I care about is the observations I'm seeing now and what makes physical sense. If I could take that physical analysis, those physical observations, and take what I know about the pattern evolution and then look for the factors that could disrupt it or not. That's how you develop a forecast. Not let's copy and paste the GFS or the European guidance for day 10 to 15, throw it out in social media and say, look, warm winter. That's not how you forecast. That's how you copy and paste. You want to copy and paste? Copy and paste. Go at it. Have fun. But when someone does that, ask them to describe and discuss the physical parameters that would give you that forecast and what could go wrong. And if they can't do that, then they haven't really thought about this pattern evolution. So, yeah, I apologize about that originally with sharing the screen. I totally forgot about that. I'm going off on a tangent and didn't even realize it at first. But we fixed it. Eye test, look at 850 millibar level, 8 on Earth New School. Looks like more cold air in Northern Hemisphere overall than last winter. Okay, let's take a look at Earth New School. Let's do temperatures. Okay, so let's see if I can pull up HD here. Okay. I really can't make a comparison. I mean, it certainly looks vast. I'll give you that. I mean, it definitely looks vast and impressive. So I'll say this: there is no lack of cold air this year. I can tell you that. There's definitely. It's not like we're like there's no cold air. There's plenty of cold air. I'm not sure about the intensity in comparison though. I really don't know yet. I don't have that data off the top of my head. Let's see here. I think is that everything? Oh boy, it's already 9:02 p.m. No, I know. I got so tied up. I got so into the forecasting, I forgot that it's 9:02 p.m. I've had some fun. So, and I'm still awake, which is something. If anyone knows me personally, I am a morning person. That's why I wake up at 3 a.m. and start forecasting because I'm insane. But so me like staying up this late is usually pretty difficult. More times than not, I'm usually up this late when there's a winter storm. But apparently, I got my second wind.
Kid on Christmas Eve.
Yeah, pretty much. So I think we're gonna call it a night. Thank you again for joining me. Oh, wow, there's a lot of you too, which is really cool. So again, thank you as always. If you're interested, definitely check out for you guys on YouTube. Definitely check out the premium consulting memberships. It's $11 a month or $80 a year. You can also do seasonal for $30. It gives you 4 months. So definitely check that out. And also we have merchandise right here. So we got that. We'll have the same discussion next week. I'll let you know if there's any changes that need to be. As we move through December, there will be different days that we're going to be doing the live chats because apparently I'm popular enough to be invited to a Christmas party. So that should be pretty interesting, right? But I better not be getting asked about doing a winter forecast while at any of these Christmas parties because I'm there to eat the little hot dogs, and that's it, But I think that's it for tonight. I will see you next week. If there's any changes to the times or days, I will let you know. But in the meantime, have a wonderful evening, and as always, stay safe out there.